Now that we've talked about the structure of bones, let's take a look at how bones form and how they grow and how they're repaired. Bone is formed by hardening of softer tissue. We start with something a little softer, and then we harden that with the depositing of bone matrix until it becomes bone. There are two different types of bone formation depending on what structure you're starting with. The process of intramembranous ossification is used to form the flat bones, like the bones of the cranium, the sternum, the ribs, and the pelvis. In intramembranous ossification, we start with layers of connective tissue membrane. Cells inside these layers of membrane differentiate or change into osteoblasts. Now we know osteoblasts are the key cells for producing the bone matrix. These new osteoblasts go about the process of creating bone matrix. They form the trabeculae of the spongy bone first, so we begin to form spongy bone within these layers of membrane. Then, as that is becoming established, the membrane layers on the outside of this developing bone differentiate into the periosteum. That new periosteum provides more osteoblasts on the outer surface of the bone, and they begin developing the compact bone on the outer surface. So in intramembranous ossification, we start with membrane, then osteoblasts in the membrane begin forming spongy bone, and then the periosteum provides osteoblasts on the outer surfaces that can fill in with the surface compact bone. The other type of bone formation is called endochondral ossification, because in this case we're going to start with cartilage rather than starting with membrane. This is the process that's used to produce most of the bones during fetal development, and we'll be looking specifically at long bones as an example of how endochondral ossification works. During the process of endochondral ossification, we begin with a cartilage model of the bone we wish to build instead of layers of membrane. That's why we call it endochondral ossification. We're actually going to see the creation of bone from inside this cartilage model. The cartilage model that we start with has a layer of perichondrium around the outside, which produces chondrocytes for the building of this cartilage matrix. Once the model is established, the perichondrium becomes the periosteum and begins producing bone cells instead. The osteoblasts produced by the periosteum begin producing a thin layer of compact bone along the diaphysis of the outside of this cartilage model. While this is occurring, cells inside the diaphysis of the model, chondrocytes in the diaphysis of the cartilage model, begin to die. And this opens up a space in the diaphysis of the model. Blood vessels and cells from the periosteum can penetrate into this space. This forms what's called the primary ossification center. This is where we're going to be building the bone from the inside of this cartilage model. From this primary ossification center, our osteoclasts go to work breaking down the cartilage, while osteoblasts are replacing it with bone. As this process of ossification works from the center of the diaphysis up towards the ends, we have establishment of a secondary ossification center in the epiphysis. Cells in the epiphysis will die, blood vessels from the periosteum will penetrate into the epiphysis and begin creating bone there. This is the state of most long bones at the time of birth. We have a nice bony diaphysis and we're beginning the process of creating bone in the epiphyses. Soon after birth, spongy bone has filled the epiphyses and we're only left with cartilage in a couple of key areas. We still have cartilage remaining on the ends of the bone that will be the articular cartilage, allowing smooth movement between the bones, and we have a band of cartilage between the epiphysis and the diaphysis. That is the epiphyseal plate, and that is where growth occurs. During the rest of childhood and early adolescence, the bone is going to continue to grow in length as the cartilage in those epiphyseal plates divide, and in width as we deposit more bone around the outside and remove bone from the inside of the diaphysis. By the early 20s, all of the cartilage in the epiphyseal plate has been hardened into bone, into an epiphyseal line, and at that point, the bones can no longer grow any longer. However, they can still grow in width and be remodeled somewhat. Let's talk a little bit more about how bones grow. Bones are only going to grow in length as long as there's still cartilage in the epiphyseal plate. The chondrocytes in this cartilage divide and produce new matrix, making more and more cartilage, which pushes the epiphysis further and further from the diaphysis. As the epiphysis is being pushed away from the diaphysis by the growth of new cartilage, the older cartilage is beginning to die. The chondrocytes enlarge and they die, leaving behind spaces. In these areas, osteoclasts come in and remove the cartilage matrix, and bone matrix is deposited by osteoblasts, forming a continual process of creating new bone following the movement of this epiphyseal plate. That will continue until all of the cartilage of the epiphyseal plate is hardened into bone, leaving the epiphyseal line and no more opportunity for bones to grow in length. In this X-ray image of a child's hand, we can see a lot of epiphyseal plates. In this case, the hand is still growing, and every long bone in the hand has an epiphyseal plate. We can see the diaphysis and the epiphysis as lighter color because this is where the bone matrix is blocking the X-rays from getting to the film. But in between the diaphysis and epiphysis of each bone, we see a darker layer, and that is where we have our epiphyseal plate made of cartilage. While bone growth in length ends by the early 20s, the bones can grow in width throughout life. Growth in width is called appositional growth. In order for bones to grow in width, osteoblasts in the periosteum produce new compact bone along the outside of the diaphysis, while at the same time osteoclasts in the endosteum inside the bone remove the bone matrix from the inside to widen the medullary cavity. This is an important process because if we kept growing new bone on the outside without removing any from the inside, we have really thick, compact bone that would be really heavy. So we have to widen the medullary cavity from the inside with the osteoclasts as we build bone on the outside with the osteoblasts. In addition to bone growth, we have bone remodeling going on throughout life. Bone remodeling is removing of old bone matrix and building of new bone matrix. This is important for a number of reasons. First, we need remodeling to fix tiny breaks or microfractures that are found in the bone matrix. We remove the damaged matrix and rebuild new matrix. We also need bone remodeling in order to release calcium into the bloodstream when necessary. We have to break down bone to release calcium, and if there's enough calcium, we can build bone back up again. It's also important to have remodeling to adjust the bones to their use. The more we use the bones, the more we stress them, which stimulates the activity of osteoblasts and builds more bone. The less we use the bones, the less stress there is, the less osteoblast activity, and the more the osteoclasts can remove bone. One of the best ways to keep bones healthy is to use them to stimulate that osteoblast activity and make sure that you're constantly renewing the bone matrix.